Hello, this is Libang. Let me share my screen real quick. Um, so um, so one of my part of work is to visualization. Um, I'm mainly focus on the clustering test clustering. So our methodology is use Xinyi cluster to calculate the numerical value of the document vector, as you can see. Um, so once we group by each cluster, then each cluster is associated with keyword. Um, in addition, we calculate like the frequency of the most common keyword in the cluster, then use this cluster um, keyword to do visualization. Yeah, let's. So first we explore the data set. We we do the basic data cleaning, such as like convert string to the list of floats or convert list of float to numpy array. Um, yeah. Uh, so um, so first we use elbow method to find the optimal k. As you can see, uh, k equals 6 is a value of k at the elbow, right? So the point after which the distortion start discretion in linearly. So that's why we choose k equals 6 as our k. So a set of number of cluster equal to 6 to fit a K-mean model. So once we fit a K-mean model, um, we group by each cluster. Which group by cluster, and then use and calculate the frequency of the keyword. You can see the first word, the most frequency of words, the most time of the frequency word is AI. Second one is research, like etc. Then after so after obtaining the data, we conduct basic data processing, which include like removing stop words and make sure every ensure the uniform formatting, and based on frequency of each word, we visualize like top 50 common word using Python word count. Yeah, as you can see, the class 0, the most frequent same word is scientist. Class 1, the most frequent same word is US. Yeah, that's all. Yeah, thank you for watching.
Hi. So now that we knew how we implement this clustering algorithm from Libang, now I'm going to show you how we integrate all the script together to form our final project. So the first thing for this lab is to ask us to get the vectors for each of the message, right? So I defined a function for that. That is to use the doc2vec and to put each of the message as a tag inside this document and train the model using the pre-built doc2vec. And I returned the processed data frame as well as the model itself, because in our following steps, we're going to input a user inputted strings and calculate the similarities. So we need both the model and the processed data frame as well. And then the information clustering, I think my teammates have stated pretty well. So what I did is to convert what he did into another file, which contains a function called k-means clustering. In this function, I did the model training and implemented the cluster algorithm, and actually created another column called cluster to store all of the cluster information and return the process data frame for future use. And now it's time to integrate what we did last week into our final project, which is this file, scraper.py. This is what we did for last time. So I defined a function called the get data. So what this did is actually to scrape all of the post messages from the original URL, and everything is just the same as we did. So inside our automation script, I imported all those files here, and also created some other functions, for example, storing and fetch. That is to store the data frame onto MySQL database and fetching the data frame from MySQL database. And now here is our main function. Because we actually want the script to be automated every minute the user input. So what I did first is to check whether the user input is quit and actually is a number. So if user input a number and is not quit, I'm gonna implement this while loop. First is gonna show the user that we are trying to update the database. If you don't type in quit for the next few seconds, then we're gonna implement the whole algorithm. This line is actually just to track whether user input anything in our sleeping process. So if there is a user input and it's called quit, then we're gonna break the loop. If user doesn't input anything, we're just gonna scrape the data to get the data. We call our scraper function, our word to vec model function, our clustering function, store the data frame in a sequence. And after storing the data frame, we're gonna let the system sleep. If user actually want to quit during the system sleeping process, they can also type in quit here as well. They just don't need to wait until the scraping process enter another loop. And also, if the user enter a non-numeric one, that is, if they want to retrieve information based on our clustering algorithm, we can also let the user type in a keyword that they want to check, and we're gonna put their input into a list called search, and we add another keyword called tag with the user input, because actually what they did is to search under the tag subreddit, right? So they should assume that the information they inputted is related to tag. So that's why we did this appending. And then we calculate the similarity between the data we scrape from the website and the user input. We get the most similar instance from our data, and we build another data frame which documented every cluster with its keyword. So we can actually map the cluster which has the most similarity with the user input and retrieve all of the keyword and the content from the original data frame. And we print it out to let the user know what has been retrieved based on our algorithm. So let me do a demonstration for you. So if we want to let the system keep updating for our inputted time interval, for example, this time I input 1, then it's going to show me that it's updating. Now I can input quit, but it's not necessary as this is only the first loop. After 5 seconds, the script is gonna scrape data from the website. So this may actually take a while, but let's just wait. Okay, now the scraping process is end, and now it's extracting keywords and getting vectors, storing the database. We can let the system sleep to see if our updating process is functioning well. Now the system is going to sleep for 1 minute, which we inputted, and it's going to repeat the whole process again if we don't input anything. Okay, now I think the sleeping process is end. And you can see that another loop has been appearing. We can do nothing and let the whole process run again to check if everything is going on well. Okay, so now we can see that the second loop has been functioned well. And we can type in quit at this point. So after system sleeping, it's gonna quit. Okay, you can see that we successfully exited the program, and now let me do a keyword tracking. For example, if you want to see if there's anything related to battery, let's see. Okay. So actually this data is retrieved automatically from the MySQL database, so it's really fast. And we can see that the vector, the cluster that I'm getting is cluster 0, and the keywords we're having is robotic, like skeleton, the simulation system, patients move, automatic driving system, national, and stuff like that. And the message it got, you can see it contains something like national NASA battery tech to deliver for the grid. And I think it's pretty, yeah, electronic nose, blah, blah, blah. I think it's pretty related to our input. So this is how, this is what we got from now. Thank you for watching.